right, ladies and gents, so I'm going to do a brief tutorial on how to get started on the mathematics of horizontally launched projectiles. Just call your attention to what we've studied or investigated so far. The very first day, on Monday, we looked at this apparatus. Remember, this ball was knocked off sideways, so it was given an initial horizontal velocity, and this one fell straight down. And you've also then hopefully watched a Mythbusters about exaggerating this. What about a gun? Firing a bullet at bullet speed and the other bullet just dropping, and you've hopefully seen the results of that. Now we're going to take a look at sort of the mathematics. And if you remember, the key takeaway is these things hit the ground at the same time. The bullet, whether it was fired or dropped from the same height, hit the ground at the same time. So let's just take a look at this simple worksheet to begin the mathematics. So you'll get this worksheet from the sub, but let's just take a look at what's happening. They've broken the motion up into two directions. We've got one that's moving purely in the horizontal here, and we've got one that we might say is just purely in vertical free fall. Let's look at the simplest one first. This is something that I never really understood as a kid, but I used to think that somehow an object, if you threw it or hit it or pushed it, somehow carried that push with it, and it might continue to speed up. But we know now that that's not the case. So the motion map, once something leaves this pitcher's hand, it's going to go at one constant velocity. We're going to learn real soon that there's no force to cause it to accelerate. So it's going to move at one constant velocity. That velocity we might call Vx. It's Vx in the x direction. And we know how to solve for that. It's just a change in displacement over a change in time. And if I wanted to solve for the range or the displacement, it would be Vx times the time the thing is in motion, right? So again, pretty simple physics. Let's look at this one next. Now this one is not going to be constant velocity. It's going to be in free fall. In other words, it's going to be accelerating. And the equation or the mathematics that we use to guide our thinking there, put it where I think I'm going to have space, it comes from this, and you've been quizzed on this already. VIT minus 1/2 GT squared. We're dropping it in this case, so that becomes 0, and this simplifies to delta y equals minus 1/2 g. Let's make g 10 for simplicity, so 1/2 g would be 5t squared, and then they're giving us a scale here that says 1 centimeter is 5 meters. So what I'm going to do is go ahead and use that and figure out on this scale where should that ball be every second. Well, we know at time equals 0, it's still in the person's hand. He's just dropping it. If I plug in 1 for t, I get 1 squared times 5. It's going to be 5 meters down on that scale. It's going to be right here, right? Because 1 centimeter is 5 meters. So I'll do the next one then. What if I plug in 2 for t? That's going to be 5 times 2 squared. That's 5 times 4, that's 20. So on our scale, that would be here. Right. I'm going to pause the video and finish. I want you to pause the video also and try to get all the way down to the end. Where is it going to end? So we got it all the way down in this case. So remember, this one was in free fall, and the mathematics to describe its displacement given a time is from here. This is not in free fall. Horizontally in the x direction, it's moving at one direction, at one speed, and the mathematics doesn't include an acceleration term, right? Because it's moving at a constant speed. So what actually happens when something is moving both ways at once is not some weird combo of these, but both of these exactly happening at the same time. And I'll show you how to put that together. So the first part, we're just going to connect these points in space. First one would be here. Second one, horizontally it's gone this far. Vertically it's dropped this far. So where do we actually see it in space? We see it here. Right? Again, this one horizontally goes this far. Vertically, it drops this far. It's doing both at once, so we see it here. I think you get the idea. Drawing a line down here. It's traveled further, so it's traveled further horizontally. It's also had more time to fall, so it's lower. And then finally, the last one be somewhere around here, and we can imagine then that parabolic path that we're seeing. So the key takeaway here is there is no new mathematics. There's no new mathematics for a projectile that's moving in two directions. There is mathematics for the constant velocity in the horizontal, and there's mathematics for the free fall in the vertical. And the key takeaway is the time is what ties these together. While it's moving horizontally, it is also falling. And if we can put those together, we can solve problems and we can make predictions. So what I want you to work on in the remainder of this class with the sub is a couple things. A, if you haven't finished your golf simulation, the golf range simulation from Gizmos, do that. Solve your problems from this week. So look on the classroom for that. There's 4 problems posted on page 98. And do the Nobel Prize investigation. I think you'll find that this one is pretty interesting. All right.